Hello everyone. We are seeing the how to solve the minimization problem in LPP through graphical method. Okay. So let's see the problem. We have to use the graphical method to solve the following LPP problem. Minimizing z is equals to 4x1 plus 6x2 subject to the constraint equations are x1 plus x2 should be greater than or equals to 8. 6x1 plus x2 should be greater than or equals to 12. Where x1 and x2 should always be greater than or equals to 0. Let's start the sum. So the first step is to convert the inequality sign into equality sign. Okay, so we have to convert the inequality sign into equality sign, and the equations will become as x1 plus x2 is equals to 8 and 6x1 plus x2 is equals to 12. Now we have to solve these equations to get the coordinates of each equation so that we can draw the line on the graph. So to get the coordinates, we have to assume x1 and x2 as 0 to get the coordinates. So let's say equation x1 plus x2 is equals to 8. x1 assume as 0. So x2 will become as 8. Okay, 0 plus x2 is equals to 8. x2 is equals to 8. Next, let's assume x2 as 0. So when x2 is 0, it will become x1 plus 0 is equals to 8. So x1 will become 8. So the one coordinate will be 0, 8 and another coordinate will be 8, 0. As already mentioned in our previous video for the maximization problem, x1 is always considered as the x-axis variable and x2 is a y variable, y coordinate. Y-axis. Okay. So 0, 8, 0 being x1 and 8 being x2 and 8, 0, x1 being 8 and x2 being 0. So coordinates for the equation x1 plus x2 is equals to 8 are 0, 8 and 8, 0. Now similarly solve the equation 6x1 plus x2 is equals to 12. Assume x1 as 0. Then x2 will be 12. Okay, so 6 into 0 plus x2 is equals to 12. 0 plus x2 is equals to 12. So x2 is equals to 12. So the coordinate will become as 0, 12. Next, let's assume x2 is equals to 0. So 6x1 plus 0 is equals to 12. 6x1 is equals to 12. So x1 will become 2. So it is 2, 0. Coordinates for the equation 6x1 plus x2 is equals to 12 are 0, 12 and 2, 0. So we got two equations. We got two coordinates for each equation. So now draw the equations on the graph. Okay. So for the equation x1 plus x2 is equals to 8, the coordinates are 0, 8 and 8, 0. We will identify those points and we will join those two points and make it an equation for x1 plus x2 is equals to 8. Then for 6x1 plus x2 is equals to 12, the coordinates are 0, 12 and 2, 0. We identify those points. We connect those 2 points and make it the line for the equation 6x1 plus x2 is equals to 12. For minimization problem, we have to consider the outer area as against in the maximization problem. In maximization problem, we have to consider the inner area. The minimization problem, we have to consider the outer area. Okay, so we have considered the outer area. So the 3 points that are here are A, B and C. Okay, so A coordinate we know as 0, 12. B coordinate we know as 8, 0. C value we don't know. C is an intersection point for both the equations. So we have to solve both the equations to get the coordinates of C. Okay. So both the equations are x1 plus x2 is equals to 8. 6x1 plus x2 is equals to 12. So we are subtracting the equation 5 and 6. the x2 will get cancelled. So x1 minus 5x, 6x1 is equals to 8 minus 12. So we'll get minus 5x1 is equals to minus 4. X1 will become 4 by 5, that is 0.8. Now we substitute the value of x1 in the equation 5, that is x1 plus x2 is equals to 8. The value of x1 will get substituted as 0.8. So 0.8 plus x2 is equals to 8. x2 is equals to 8 minus 0.8, that will be 7.2. So the coordinates for C are 0.8 and 7.2. Now we got the coordinates for all the 3 points A, B and C. A coordinates are 0, 0, 12, B coordinates are 8, 0 and C coordinates are 0.8, 7.2. Now we substitute these values in our objective function to get the minimum value. The objective function that is given in our question was 4x1 plus 6x2. So we substitute the value of each coordinates in this equation. So A coordinates are 0, 12. So 4 into 0 plus 6 into 12 will get the value of 72. B coordinates are 8, 0. We substitute the value in 4x1 plus 6x2. It will become 4 into 8 plus 6 into 0. It will become 36. The coordinates of C are 0.8 and 7.2. So 4 into 0.8 plus 6 into 7.2, we get a value of 46.2. Here if we compare 3 coordinates, the point B is having the minimum value of 36. So B is our answer, where we can say that at point B company will have the minimum value. So this is the solution for minimization problem through the graphical method. Thank you guys.